Good afternoon to everyone. My name is Agendra Kumar. I wasn't here for last 2 days, so and I wanted to be here and speak with you for a short while. So how are you finding this conference so far? Good? Right? How many of you have come only for this AI session? Quite a few. Okay, good. So this session is going to be really exciting. AI is the in thing today. Everybody talks about AI wherever you see, and there are lots and lots of capabilities in ArcGIS today. And we also have a good team in India to support our users. Just to put a little bit of perspective around this, though I'm not a technical person, you are all technical people. You use our technology, so I want to thank you for that. Thank you for being our users and doing wonderful things with ArcGIS and all the tools that ArcGIS comes with. And in last 2 days, I think we've spent a lot of time in covering the new features and tools which are there in the technology for building new applications. So having you here is really important for us, because if we do not tell you about what good things we have, and if you do not know about them, then probably your organizations will not get all the benefit of having ArcGIS technology, Esri technologies that you have. From our side, Esri India has built, and we continuously keep expanding our capabilities to support our users in India. Today our team is about 800 people in the country, which is quite a sizable number, and most people are technical. Very few people who are non-technical in the organization. We also have invested in a lot of geospatial content. I think day before yesterday, my colleague Kamlesh spoke a little about that. So investment in content was really strategic for us, because it's helping us today when we are trying to apply AI. We have a lot of data available. You have a lot of data available. So our investment was in content which is a part of Living Atlas, all the open content which is published by different government departments. We geo-reference that and publish on a cloud hosted in India. And these are hundreds of layers which are available now. We invested in providing you base maps, good quality base maps, raster and vector maps, wherein all the large cities are in 30 centimeters and rest of the country is in 60 centimeters, quite a good data quality. And many organizations are adopting our base maps in their organization. So that's another big investment. Then also we made investment in points of interest and other demographic data, because in many situations that also helps quite a lot. So that's a very important investment we made, and my colleague Vijay might have spoken about our other investment in a center for AI and GIS. It's a competency center that we opened last July in Noida. So that's a center which is a resource center. We have a lot of people there. We have engineers. Some of them will be showing you good demos which they have created for this particular conference. But then the objective of this center, it's not an R&D center. It's not something where we are trying to invent things. It's an enablement center. Through our GIS and AI competency center, we want to help our users in India in adopting AI into their workflows, in their applications. So that is the primary objective, and I'm happy to say that we probably supported more than 100 customers already through this team. So and it's a very successful adoption. We help in organizations successfully adopt ArcGIS and AI. So that's the primary objective of that center. And over a period of time, we have seen that the kind of use cases which are being built by our users, I think it's improving quite a lot. It's all happening at the world-class level. I will not take names of any specific users, but applications for land management, forestry, mobility, railways, shipping, port management. So there are a number of areas where GIS and AI is being used very well in the country. And those applications are at the same level that you will see in any other country across the globe. So very good work being done by our user organizations today. And I think it's a partnership. It's a partnership between you and us, wherein we try to enable you, try to provide you more information through this conference, and then in September we'll have a user conference. So that's another platform where we share information. It also becomes like a platform for you to talk to your peers from different organizations. So those are some of the other objectives of having this kind of event. And we also, we are a CMMI level 5 company. So I think the capability that we have built internally to help customers in building those applications through our resources, also at a fairly high level of maturity. And that's one way we provide some additional value to our users in India. So these were some of the thoughts which I wanted to share. You will hear a lot about AI, but it's a very exciting field. ArcGIS has a lot of AI capabilities, Geo AI, building AI assistants, agentic AI, all those technologies are there. And it's managed through a framework wherein all these different facets of AI become a part. And advantage of framework is that it can evolve, continue to evolve. It's not a point. It's a framework which will expand as the AI technology also matures more. So thank you very much. I'd like to invite David. Thanks.
Okay, thank you, Agendra, for your hospitality and those inspiring words. Okay, so let's get the AI Summit kicked off. And really, we're going to spend some time before lunch and some time after lunch talking about AI and how it's driving the work that we do in ArcGIS. But before we look forward, let's take a quick look back. ArcGIS has always been embracing the latest technology trends, and many of you, all of you, have been on this journey with us. If we think about it, in the early days, and I think I was alive for the mini computers, but in the early days we had mainframes, workstations, microcomputers, and then of course came along personal computers where we had Windows with the innovative UI at the time, and of course mobile computing where maps were in the palm and the pocket of everybody. And then we continued to evolve. We started to harness GPUs to power intensive geospatial analysis and 3D visualization. And today we're really riding the crest, the wave of cloud computing and networks everywhere. And the rise of AI and large language models, LLMs, we see the need for compute, the need for cloud storage just increase exponentially. And this history isn't just Esri's history, it's also your history. So all of you in this room have modernized your GIS as these trends have become more popular, tested, tried, and true. So you're along this journey with us. In fact, this journey, from our perspective, has been guided by one purpose, and that is to improve our quality of life, your quality of life, help you improve your customers' quality of life through the use of GIS. And ArcGIS is empowering yourselves and other organizations to leverage spatial intelligence every day to do this. And really, it's changing the way in which we live. So our window into geography and how geography can give us location intelligence with every workflow that we implement every day really is quite powerful. So why now? Why is 2026 a pivotal year for geospatial AI? Well, there's a few big reasons as we see it. AI has made a huge leap forward. In just a year or two, AI capabilities have exploded. You can't go to a technical conference or even a non-technical conference or meeting anymore without AI being at least part of the subject that you're talking about. We have data overload as well. So we're collecting an enormous amount of data, not just location data, but there's also a lot of other related informational and field data that goes along with that. It's from satellites, it's coming from drones, it's coming from sensors in the cities that we live. And to be quite honest, it's so much data, it's too much for humans to really sift through. And so AI is essential for this type of data management, and also to look at the data, analyze it, and come back with patterns that we may not see otherwise. And we believe that spatial context is key. So generic AI is great. It's an amazing technology. But when you add location or the where factor, it becomes really invaluable. And so there's this real urgency to evolve. Technology companies are moving very fast to adopt AI. So to solve some of the problems that we have, it could be climate change, it could be public safety, that also demands faster action and more accurate results, and that's what AI gives us. And so our purpose, our response to this opportunity is our vision that you're looking at here, and it is essentially to transform ArcGIS into a complete geospatial AI platform, allows you to not only drive innovation in the work that you do, but also drive results. So we're infusing AI into really every aspect of ArcGIS. It's not a plugin. It's a core part of the system, and you would be hard pressed right now to find an area of ArcGIS in which AI isn't a part of. And so our goal is for you to be able to easily harness AI within your GIS workflows, within the environment that you work in, within the projects that you implement. So I had mentioned that in the plenary, we had mentioned that ArcGIS is advancing. Well, along with that is AI, and just to reiterate what I just said, AI is a part of each kind of category of technology that you're looking at here, from our apps, our experiences, to 3D, to the analysis that we do, to the content that we generate and serve out. So why is GIS and AI a powerful combination? Well, AI becomes more useful when it has that location intelligence associated with it. So this includes insights from massive data sets that may be detecting patterns or anomalies that would normally be impossible for us as humans to detect. AI enables real-time analysis, and it complements a lot of the traditional GIS models that we have. And AI can also automate tasks, freeing analysts, technologists like yourselves, from tedious work and allowing you to do more strategic work that AI really can't do. And so we believe that AI brings a lot of value to ArcGIS. For example, automated data creation. We're going to see several examples of feature extraction of buildings, roads, for example. Another example is automated data conversion, where we take text documents that may have some location information in it and we transform them into geospatial features. We saw a little bit of this in day one when we showed the example with boring logs. We can automate analysis by detecting vegetation or encroachment on utility lines, as you're looking at here. We can provide accurate predictions, for example, sea surface level as it rises and what impact that might have. And you're looking at other examples here. So before we get started on our first pillar, of AI, it's probably a good idea just to take a minute to talk about some key fundamentals so that we're all on the same page. And if you were at one of the technical sessions that Krishna gave earlier this morning, he did a very good job of explaining a lot of these terms. So we have AI, artificial intelligence, and it's a broad term for machines that perform tasks that typically require human intelligence, like understanding and reasoning and decision making. Machine learning is a subset of AI where algorithms learn patterns from the data without being explicitly programmed. Deep learning is a subset or a powerful type of machine learning that uses neural networks with many layers. And these deep networks excel at recognizing very complex patterns. Generative AI just doesn't analyze data, but it also returns results. It generates new data. LLMs, these are huge AI models where we can train them. These AI models provide knowledge. They provide a history of conversation, of natural language that your end users might be having with your agents. Computer vision, AI focused on interpreting visual objects in photos, for example, or imagery, object detection. Natural language processing. So AI understands natural language. We've seen several examples of that over the last couple of days. And when it comes to GeoAI means applying all of these AI techniques specifically to geospatial data and the problems that arise with geospatial data. And an AI assistant is like a chatbot, or an assistant that you can use natural language with that reasons with an LLM. It in and of itself you could think of as an agent. So here is a lot of the terminology that you've probably heard throughout the week, but you're going to hear a lot more of in the next little while. So as we add AI everywhere, trust and responsibility really are paramount. At Esri, we leverage AI in many aspects of the work that we do, but not all AI. We need to be able to trust and verify that the models we're using aren't going to have any adverse effects. And our partners, our customers like you, want the same thing. You want security and privacy. You want ethics and fairness, where we ensure the AI's behavior is fair and ethical and is void of any biases. And you want transparency and explainability. Many of us don't want AI just to jump to an action without it actually recommending that action to us and prompting us to see if we actually want it to take that action. And so when we look at the areas of work that we're doing, it really comes down to the four areas that you're seeing here. GeoAI, which empowers or powers spatial analytics, everything from machine learning to deep learning in GIS. AI assistance to allow you or your end users to be more productive with the components and the applications that come with ArcGIS. And AI agents that support autonomous GIS workflows. We'll get into details with that. Underlying all of this, though, is an AI framework, which is basically a unified, trusted AI infrastructure. And it's the foundation of all of our AI services and our tools across ArcGIS. This framework exists on ArcGIS Enterprise, within ArcGIS Pro. It underpins ArcGIS Location Platform and ArcGIS Online as well. So we're going to dive into GeoAI, AI assistants, and AI agents, and by doing so, we'll also talk about the framework that underpins it and how you as developers and technologists can take advantage of that. So Let's dive into GeoAI first, and to take us through all of the great work that they're doing, I'd like to invite Rohit up to the stage where him and his team are going to talk about all of the GeoAI work that they've been doing.
Thank you, David. Okay, so I'm Rohit Singh. I'm the director of Esri's R&D Center in New Delhi, and I'm very excited to be here with our teams to talk about GeoAI. GeoAI is about advancing the science of GIS using AI to perform mainly two things. One is feature extraction, and another is to perform advanced analysis. For feature extraction, we leverage computer vision models to extract features from imagery or point clouds. We also use natural language processing models to extract meaning out of unstructured text document. And then for advanced analysis, we leverage machine learning and deep learning techniques to build upon that foundation and learn patterns and relationships across vector, tabular, and time series data. So why do you need GeoAI? Well, in today's world, there's an explosion of data with so many sensors, IoT devices, satellites, aerial imagery. Everything is streaming down, and it's no longer even possible to use the traditional methods of analyzing all of that data, to interpret that data at scale. You really need GeoAI. That's where it comes into the picture. GeoAI enables us to scale and automate feature extraction, helping you detect patterns and unlock information from every pixel in massive data sets in a matter of minutes and hours, not days or weeks. It helps you transform that data into actionable insights, increasing your efficiency and speed in decision making. That's really what a lot of GIS is about. GeoAI enables you to solve a range of problems by transforming raw data into spatial content. That includes activities such as identifying where illegal mining is taking place, for example, automating map production workflows, detecting and quantifying where changes have occurred over time, and extracting features to create foundational GIS layers. Now let's hone in on imagery. That's an area where GeoAI really shines. Many of the problems that we discussed, tracking activity or automating mapping, detecting change or extracting features, they start with imagery. ArcGIS supports extracting meaning from a wide range of imagery sources, from aerial and satellite imagery to multispectral and now hyperspectral imagery, to 3D point clouds or even video. We recently integrated remote sensing foundation models. You might have heard about foundation models called Prithvi or the clay foundation model. You can now use them as backbones when training your own models on imagery. And that lets you train more accurate data with lesser training data and compute. To see our recent work on hyperspectral imagery, how you can use deep learning to classify hyperspectral imagery, I'd like to hand it over to Saranya. Over to you, Saranya.
Thanks, Rohit. So unlike traditional multispectral imagery that captures fewer bands or wavelengths, hyperspectral imagery records hundreds of narrow contiguous wavelength bands. This enables precise identification and analysis, opening door for advanced analytics in environmental monitoring, agriculture mapping, and several other applications. So I would like to take a minute and discuss about hyperspectral data cube. So this is a three-dimensional data set with two spatial dimensions and one spectral dimension. To extract information from this data cube, we need dedicated models like hyperspectral 3D RCNet. This is a hybrid convolution attention framework dedicated for hyperspectral image classification. This network operates in three stages: sample extraction, multi-stage feature extraction, and classification. This architecture is now available in ArcGIS.Learn, which is the dedicated module for deep learning in ArcGIS API for Python. So let's move to ArcGIS Pro and take a look at the steps. So here we have a hyperspectral imagery for the city of Ahmedabad, which has 372 bands. The first step in deep learning is to export the training data. For that, I'll go to geoprocessing and run the export training data for deep learning tool. Here, as an input raster, you can use the hyperspectral imagery as it is, or you can filter it using techniques like principal component analysis, which helps in dimensionality reduction and to reduce the correlation. And for the input features, I have a classified raster here, which has 5 classes: barren, vegetation, water, built up, and road. You can export it in classified tiles metadata format. Once the export is done, you can move to ArcGIS notebooks. Using ArcGIS.Learn, you can import the necessary libraries, prepare the training data, call the model, and start the training. You can see that within 5 epochs, we were able to achieve closer to 100% accuracy on the validation data set. And these are some of the sample results. To use this model and do the classification on the entire scene, you can use classify pixels using deep learning tool and call the model we just trained in the notebooks. So let's take a look at the result. So now we have a high resolution land use land cover map for the entire scene. So to summarize, we saw how ArcGIS.Learn now supports dedicated model for hyperspectral image classification. The same workflow can be used for agriculture mapping, forest cover mapping, mineral mapping, and so on. Thank you. Over to you, Rohit.
Thank you, Saranya. Okay, now let's switch gears to another important data modality, which is unstructured text. Now, as you know, geospatial data doesn't always come nicely packaged in the form of GIS layers that you can just use. Sometimes the most valuable information is buried deep inside text-based reports or news articles or incident logs. And that's where natural language processing, or GeoAI for text, comes in. ArcGIS has tools and pre-trained models to unlock geospatial insight from such unstructured text. You can classify or categorize text. You can extract entities or locations from it. Or you can transform text. Maybe you want to summarize it. You may want to translate it. You can convert it from one format to another. So whether that information comes from imagery or from unstructured text, the next question is like, who can use this and how can you use it? We've integrated ArcGIS with large language models using both a low-code approach and a no-code approach. So on the Living Atlas, we've made available these bridge or adapter models to the Hugging Face Hub, which is like a GitHub of open source AI models. To see how these models can be used for geospatial workflows, I'd like to hand it over to Rishi.
Imagine you work for a state government, tracking grievances about potholes, water supply. Every day, hundreds of such articles are posted in multiple languages. Buried inside this article is a lot of information. You have authority, person involved, timeline, all sitting here as a plain text, unstructured. Our goal today is to turn this wall of text into a smart live map. To do that, we are going to use something called Hugging Face. For those who don't know, think of it as a GitHub of AI models. They have thousands of open source models. And ArcGIS now has a native integration with Hugging Face. You don't need to write complex Python code. You just pick the model, point it to your data, and run it. I'm excited to show how to use this. Let's get into it. I have here our articles stored in multiple languages. English, Hindi, Tamil, all mixed together. First, we need a common language. So, I'm going to translate everything to English. I'm going to my Living Atlas and I'm going to download this HF text translation deep learning package, what we call a DLPK. Think of it as a bridge that connects between the Hugging Face and ArcGIS. Once we download this, we'll go back to our ArcGIS Pro, and here I'm using the transform text using deep learning tool. I'm pointing to my table here, and I have loaded the deep learning package, and this is where the Hugging Face comes into the picture. It's asking for the translation model ID. So I go to the Hugging Face. In here you can filter the models but by what you want to do. In this case we are trying to translate it, right? So I'm going to choose translation, and it filters out all the translation models, and I'll be choosing this server model because it performs well at Indian languages. I copy the model ID and simply paste it here. And I leave the source language blank because I have multiple languages, so I want the model to auto detect and translate everything to English. So to keep things moving, I have already ran these tools. Let's look at the result. We have a column with all articles are translated to English, and it is ready for the next step. Now, not all articles are about government grievances. Some are about sports, some are about movies, but we are only interested in government grievances like water supply issues. So we run a zero-shot classification model, and the process is same. I'm just using the different tool, process text using AI model, and I look for HF zero-shot text classification deep learning package, and what it does is, without any training, it reads the article and classifies it based on the labels that we provide. So without training, it does based on the labels. So that's why the name zero-shot classification. And in the labels, I type general news and government complaint. Let's look at the result. We have a new column that tells us exactly what each article is about, whether it's a government grievance or not. Simple, right? Now, these articles are long. It takes time to read end to end, and provided that you have hundreds and thousands of articles to analyze. So we are going to summarize this into 2 sentences. So I repeat the process, look for the deep learning package, pick the model from Hugging Face, and now we have condensed our long articles into readable summaries. We still have one more thing to do, that is finding out who is responsible, which organization, and most importantly, where it has happened. So we run a entity recognition model. What it does is, it looks into the article for key entities like person, organization, and location. And we have those columns now, took from the article. When we geocode this location, we have transformed our unstructured articles into powerful spatial data. Now, all of these articles are feeding directly into this experience builder. You can see all the articles are categorized by state. When I click on Ladakh, it would show me the aggregated summaries of this region. Instead of reading 10 long articles, we can get immediate awareness of the grievances that is happening in the region. And users can explore regions, review AI-generated summaries, and access structured insights. By bringing the power of Hugging Face into ArcGIS ecosystem, we have made AI accessible. So this was the look at no-code approach by bringing AI models to ArcGIS. Let me hand it over to my colleague Sribhadra to show us the low-code approach with ArcGIS.ai module. Thank you.
Thanks, Rishi. Automation of complex GIS tasks has always been easy with ArcGIS API for Python. Now, we are introducing ArcGIS.ai, a new module that brings image and text analysis into a dedicated space within the API. The AI module supports three major workflows: analyze image, analyze text, and translation. It's designed to help you move from simple experimentation to building more practical automated GIS workflows. We all know that the assets of utility network requires periodic inspection to know the asset health and maintenance need. So today let's see how we can automate the inspection of electric poles with the help of new AI module. This is a feature layer containing the locations of electric poles where inspection has been carried out by the field workers. Each location has details like pole ID, pole height, field comment, as well as an image captured by the field worker. Using the new module, we can automatically analyze this image attachment to identify the condition of the pole. Let's see how we can do that. First, we can import the necessary libraries and functions. Then, we have created some helper methods to fetch the image attachment URL from the feature layer. Here we have also created some functions to normalize the image analysis result as well as the text analysis result. After that, we can bring in the feature service containing the inspection data. Here I wanted to extract 4 details from the image: asset category, asset description, asset health, and asset condition. For example, to get asset health, I can give a prompt, identify the health of utility asset in the image, analyze whether it is damaged or undamaged. Finally, we can run the analysis using the analyze image method, which will take the feature attachment URL and the image prompt as an input. Once the analysis is completed, we can write back the result to ArcGIS. So let's see how the result came. So here, after the analysis, we got categories like asset condition, asset category, asset health, and even a brief description based on the image. Now, this enriched data can be taken to a dashboard for better visualization, and we can quickly identify electric poles at different risk levels. Let's inspect one of the electric poles which has been identified as urgent risk. So here we can see that the analyze image method identified the asset condition as urgent risk, asset category as pole, asset health as broken. It is also telling that the utility pole has fallen over a wet road with wires hanging and debris scattered around. It also identified that this damage might have happened due to a storm or strong winds. Like this, we can extract each and every details from the image. Now, let's see the text analysis capability of the AI module. While doing field inspection, field workers have brought a command And here, as you can see, the comments are often broken and even contains mistakes. To clean this, we have given a prompt to correct spelling mistakes, grammatical errors, and return a clean field comment. And based on this, the analyze text function will return us a clean field summary. Let's have a look at the output we got. So here we can see the actual field comment written by the field worker. On the right side, we can see the cleaned field summary returned by the analyze text function. Like this new module expands Python API's built-in AI capabilities by adding higher level helpers for working with image and text analysis. Whether it's extracting insights from text, analyzing images, or enabling multilingual workflows, this new module enables automation of tasks and improve efficiency. Thank you. Over to you, Rohit.
Thank you, Sri Bhadra. So that was a no-code approach shown by Rishi and a low-code approach to AI shown by Sri Bhadra. You know, GeoAI is available at many different tiers within ArcGIS. It's designed to be used by anyone, whether you are an AI practitioner, developer, data scientist, analyst, or an end user. GeoAI empowers everyone. So if you're a data scientist who likes to use Python, there's the ArcGIS.ai module that Sri Bhadra showed, and the ArcGIS Learn module, which is a library for training your own geospatial deep learning models. But not everybody is a Python programmer. And if you want to use geoprocessing tools and train models or use them, that's also possible through the GeoAI toolbox, through the image analyst toolbox, many other geoprocessing tools within ArcGIS. And then there are these pre-trained models on the Living Atlas that you can use to just get started. And there are these GeoAI-powered applications and solutions like the 3D base map solution that make GeoAI very easy to use for very focused workflows. The easiest way to get started with GeoAI is through the pre-trained AI models on the ArcGIS Living Atlas. There's a library of over 100 models that are used to solve specific use cases such as detecting building footprints, classifying the land cover, extracting roads from imagery, and so on. And in many cases, they deliver a complete AI solution out of the box. But you can also use these as building blocks or starting points when you want to customize these models to your own geography or features of interest. You can actually fine-tune many of these models. We are now seeing the emergence of a new category of models, vision language models, that can be prompted using simple English phrases to perform a wide range of tasks. You can literally ask some of these models, what do you see? Describe the imagery, or delineate water, or detect cars, and even like just red cars. And the model surprises us by giving these accurate results, relevant results that you can use to classify or detect objects or segment imagery just using plain simple prompts. Now, very recently, Meta came out with the segment anything model. You might have heard of the SAM model. They came out with segment anything model version 3. And we've recently integrated that model as a deep learning package. And to see how you can use that using text prompts for feature extraction, I'd like to hand it back to Rishi. Over to you, Rishi.
Thanks, Rohit. Traditionally, object detection models need to be trained on specific types of objects, and that requires computing power, time, and setup before you can start using them. Segment Anything Model 3, that is SAM3, is different. It's a foundation model that can segment literally anything. You don't need to train them. You just describe what you want in plain text and it finds it. And now, through GeoAI tools in ArcGIS Pro, SAM3 is directly accessible via Living Atlas. You can download this as a deep learning package. Let me show you how to use this in ArcGIS Pro. I am working with the urban development team. They have an aerial imagery. Their requirement is to map every asset in this area. Traditionally, weeks of manual effort, but let's test it with SAM3. I have here the detect objects using deep learning tool. I have loaded my aerial imagery. I have loaded SAM3 model here in the model definition. And first, let's say I need vegetation to detect green assets in my area. I go to the prompt and type vegetation. Let's look at the results. We have every patch of green, trees, shrubs, and parks detected automatically with the prompt. Now let's detect some buildings. I go to the prompt and type buildings. Every rooftop, every structure is segmented and detected. What if I want multiple features at once, like cars and bikes? I go to the prompt and type cars, bikes, separated. That's how SAM3 handles multiple features in a single run. And the model was able to pick up even more features such as solar panels, heavy vehicles, and autos. And we can detect more features by the prompts. Now, this is where it becomes operational. All of the features that we have detected is directly feeding into this dashboard. We can see number of buildings, vegetation area, solar panels, bikes, and we went one step ahead to analyze the solar adoption in this city based on the building and solar panels that we have detected. Imagine what this means for a city administrator. They no longer need to wait for weeks of field survey. Raw imagery comes in, GeoAI processes it, and dashboard updates. From raw imagery to operational intelligence in a single workflow. Thank you. Over to you, Rohit.
Thank you, Rishi. Yeah, that was very interesting. And while these pre-trained models are powerful, many of you need to train custom models for your geography, your data, features of your interest. And this is especially true for specialized use cases such as identifying species or habitat mapping, where your domain knowledge and the local context really matters. ArcGIS provides tools to train and customize or fine-tune these models for your own needs in ArcGIS Pro, Enterprise, and Online. You can also integrate ArcGIS with third-party models, including open source models like SAM3. In fact, that SAM3 model was integrated with ArcGIS using Python raster functions and made available on the Living Atlas. And you can also integrate these with cloud AI services using similar Python inferencing functions. Now, one such tool that we've added recently to ArcGIS is to predict missing values with AI. You know, geospatial data isn't always perfect. Very often, real-world data has gaps, missing data. So how can we use AI to intelligently fill in those gaps? And to see an example of that, I'd like to hand it over to Sandhya.
Thanks, Rohit. I'm going to demonstrate how we can fill missing data directly inside ArcGIS Pro with the new Predict Missing Values using AI model tool. Imagine trying to navigate a map to understand nitrogen fertilizer consumption at a district level, only to be faced with a sea of null values as shown in red. Dealing with such gaps is now much simpler thanks to the imputation AI model support in ArcGIS Pro. Our foundation for this demo is the ICRISAT district level fertilizer statistics from 2015 to 2020. A closer look at the attribute table reveals negative values. These are our missing data points. Let us focus on one specific column, nitrogen consumption per hectare of net cropped area. While this target variable has few missing values, the supporting columns like total nitrogen consumption and nitrogen share are fully populated. Similar is the case with phosphate and potash. We can leverage the columns where the data is not missing as predictors to accurately impute the missing values of NPK consumption per hectare of net cropped area and gross cropped area. If you look at this data spatially, anything highlighted in red represents a missing nitrogen value. The blank areas are where the data was completely missing in the original source, so we are skipping those districts in this analysis. As I run through the timeline from 2015 to 2020, we can see these red areas shifting and persisting throughout. Nearly every single year suffers from these data dropouts. To fix this, we go to the GeoAI toolbox. Under Feature and Tabular Analysis toolset, we have this new tool named Predict Missing Values using AI model. The workflow is pretty straightforward. I input my dataset, I specify my target columns where there are missing values, I load my model definition file. Currently the tool supports two imputation based models, DistilGPT and XGBoost. These will be made available through the Living Atlas. Then I simply hit run. For the sake of time, I have already generated the results. In the output, as I move through the timeline, you can see these red missing zones have been seamlessly filled with imputed values. Let us have a look at Maharashtra and Uttar Pradesh. In 2020, these states were almost entirely in a blind spot. In the imputed values, the consistent spatial and temporal patterns indicates our model is learning intelligently rather than just guessing. Instead of relying on interpolation using a single column, we have now explored using AI models that understand the relationship across all the columns in the dataset. It even respects the underlying logic. Let us focus on Uttar Pradesh. In 2019, where the data is not missing, there seems to be a pattern where the net consumption is always higher than the gross consumption. In 2020, where the data is missing, the imputed results also maintain this exact relationship between the net consumption and gross consumption. This highlights the advantage of a multivariate approach. By analyzing all the variables together, the model captures the internal logic that a single column method might miss. Now that major portion of my data is complete, to fill these remaining gaps where the predictor columns weren't available, I can take it a step further and use the Fill Missing Values tool to run a quick spatial averaging with the nearest neighbors. This is how the final output looks like. I'm only focusing on the agriculture predominant districts. To wrap up, we took dataset with missing temporal and spatial values and transformed it into a complete continuous timeline. We've turned raw data into analysis ready data, all within ArcGIS Pro. Thanks, and back to you, Rohit.
Thank you, Sandhya. Okay, so we are in the middle of a lot of change, exciting change in this world of AI, and that change is coming to Geo AI as well. we are now seeing the emergence of foundation models which are changing how we do many of these geospatial AI workflows, such as predictions or finding similar locations, detecting change, or clustering. You may have heard of foundation models. LLMs are a kind of a foundation model. These are large-scale, deep neural networks, often with 1 billion or more parameters, with a lot of capacity to learn, that are trained on broad and diverse data, often multimodal data, and they are trained in a self-supervised manner, meaning even without any target labels. The model learns to distill the meaning from that data in the form of what's known as embeddings, and then that distilled representation can be easily adapted to many different kinds of tasks, a wide range of tasks using just lightweight methods like machine learning or similarity search. So Esri is now creating its own geospatial foundation models. Under the hood, these models are able to capture the meaning of that data and turn it into geospatial embeddings, which are really just a sequence of numbers that computers can easily process. These numbers understand, and they kind of distill the signal from, remove the noise, only capture the signal present in that data. And at Esri, we are uniquely positioned to drive innovation in this space by leveraging our deep geospatial expertise, the authoritative Esri datasets, and flexible GIS deployment patterns across the desktop, enterprise, and online. And as part of this work, we are creating our own geospatial foundation models, including location embedding models, remote sensing foundation model, and a geospatial vision language model that we had shown on the first day. Now, these are currently in active R&D. We are working to make them available for use within ArcGIS very soon. This is what the geospatial embeddings produced by these models look like. So in the examples on the left, it's using a location embedding model, and for each point location, it turns it into this sequence of numbers that you see in the table at the bottom, that attribute table. In the middle, we see a visualization of the vision embeddings. So you see the raw imagery, and on top you see the geospatial vision embeddings from that imagery, and you can see how it's already capturing many of these patterns present in the data. And in the example on the right, you see how we've actually used vision language embeddings from our upcoming GeoVLM model to detect just the container cranes using text prompts. So these geospatial embeddings represent each place or location as a series of these numbers that computers can easily process and perform instant similarity search or pattern recognition. These numbers go beyond just the latitude and longitude of that place. They capture socio-economic or environmental or demographic patterns from their training data, enabling predictive modeling and powering advanced geospatial workflows like finding similar features or interpolating missing values. To see how we can use similarity search on these different kinds of embeddings, I'd like to hand it over to Saranya.
Thanks, Rohit. Let us see how we can do a geospatial similarity search using location encoder model and embedding toolset in ArcGIS Pro. So location encoder is a geospatial representation deep learning model that encodes geographic coordinates into meaningful embeddings. By learning about the relationship between satellite imagery and the geographic coordinates, the location encoder captures environmental and physical characteristics corresponding to a location. This can be used for multiple tasks such as classification, regression, geospatial data enrichment, and geospatial similarity search. Today, I want to identify the locations that are geospatially similar to the snow-capped mountains of Himalayas. To do this, I will first run generate embeddings using AI model tool and call the location encoder model. This tool generates embeddings for all the points that are present in my search area. Second, I will run find similar features using embeddings. This tool adds a similarity score for all the points that are present in our study area. This can be better visualized as a heat map. Now, to understand this better, I have also run the hotspot analysis. Here, all the points that are in the darker shades of red represent locations that are closely similar to the selection we made earlier, and the gray points represent locations that are not similar. So, how else can we use this analysis? Interestingly, we found that this can also be used to identify mining areas. To do this, let's move to central India. And to pass few polygons to the tool, I have already captured few prominent mining areas. So first, I have already generated the embeddings. I will run find similar features using embedding tool and pass these polygons as query features. So these are the results. The hotspots represent areas where mining activity is predominant. To validate the results, I have also added validation polygon shared by the subject matter experts. When you look closely, you can observe that most of these polygons are coinciding with the hotspots generated by the encoder model. We can zoom into one of these locations to understand the underlying imagery. With just 3 samples, the encoder model was able to pick up the signal and help us identify all the mining areas in our study area. Moving on, location encoder models and vision-based embeddings can also help in capturing visual patterns in high-resolution RGB imagery. To see it in action, let's move to a plantation in Northeast India. So the contractors are usually paid by the number of pits that are dug every day. Manually counting them can be quite time consuming. So this is where similarity search using vision models can help. To do that, I have a 2D imagery of the same area. Using find similar feature, I'm calling the vision-based embedding. So we have already generated the embeddings for this region and selected few pits as samples. Now when you hit find similar, the tool scans the entire imagery and highlights all the grids that are similar to the selection we made earlier. Wasn't that quick? If I want to run this analysis on a larger extent, I can run a geoprocessing tool, find similar features using embedding, which we saw earlier, and here are the results. So we captured the pits not only in this hill, but also to the adjacent one. And the same workflow can be used to capture several other unique patterns as well. For example, I have another plantation pit which is crescent shaped. This is unique to the hills of Himachal Pradesh. Using the same workflow, we were able to capture the pattern. So to summarize, we saw how you can do a geospatial similarity search using location encoder model and how you can capture visual patterns in high resolution RGB imagery using vision embeddings. Thank you. Over to you, Rohit.
Thank you, Saranya. So that was a quick tour of GeoAI across ArcGIS. This combination of GIS and AI is very powerful. Not only can you use it to let AI take care of the drudgery of our work like feature extraction, but also use it to solve some of the more complex challenges facing our world.